Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to look at something very interesting in solving today. We are going to look at resection. In solving there are different methods we use to locate points, right? Sometimes you can use traversing, triangulation, trilateration, any other field procedure you want to use to locate your point. However, we are going to look at a method called resection today. We are going to solve a mathematical problem on that method. So before we solve the problem, let's look at briefly just a brief explanation of what resection is. So resection is also called free stationing. So it's the method of locating a point by observing from that unknown point to known point, from that unknown point to what? To known point. So as you can see on our screen now, we have 3 points. We have point A, point B, and point C, right? Good. Now we know points A and point B. However, we don't know point C. So what resection does, or the idea behind resection, is that from point C now, you can now make observations to point A and point B, thereby identifying, or let's say locating, thereby locating this point C, be determining the coordinate of what? Point C. Now there is one, let's say a popularly used example, which is the GNSS. The GNSS has 3 segments, right? The user, the space, and the control segment. Now we are under the user segment, and we have our different data collectors and our different receivers. Now the space segment, where we have the different satellites whose positions are known, are now connected to our user segment, thereby enabling us to locate our point, using some of those calculations and maybe some adjustment procedures and all of the mathematical procedures involved in it. However, the idea is that when you have your receiver at a point on the surface of the earth and you don't know the location, but by connecting with your receiver to the satellite in space, you can actually determine your unknown point. So that can serve as a generic example of how the process of resection works, because you can be on point C, then those satellites, because at least you need to connect to at least 3 satellites or so, I think 3 or 4, if I'm not making a mistake. So it's more than 2 actually. So you need to connect to at least 3 or 4 satellites in space, which will now enable you to do what? To identify what, or to locate your point what? On ground. So having given the brief explanation and the application of what resection is, let's now look at the question we have with us. Also, there are different conditions that can maybe warrant you to perform resection, or maybe to adopt resection as the field procedure on site, but that depends on the condition you have there. So now from the question, we are given that, or it was said that with the following data, determine the coordinates of point C. So the coordinates of points A and B were given to us, and 2 observed angles were also given to us, an observed angle at point A and another at point B, right? So now this is a sketch of the question. Now from this sketch, we have been able to identify our angle A, angle B, and then the C variant here, because we just use C. But so when you look at it now, you see that this angle A, which is represented by alpha, is here. This angle B, represented by beta, is here, and the C variant, which is angle C, has not been identified, or we don't know the value yet, right? So we are going to do that. Now, from the coordinates of A and B, let's get the distance and bearing between them. That means let's get the distance and bearing between what? Between line AB, because they are the points, point A and B are actually the points that are known. Therefore, we can easily get what? The distance and bearing between them. Thereby, they will serve as what? As our baseline, because they are actually our baseline, right? Good. So now from the coordinates, we can actually get what? Our distance and bearing. So how do we get the distance and bearing from the coordinates? We can actually get that by carrying out back computation as we do usually. By carrying out back computation, we simply mean, getting the delta nothing, delta easting from the coordinates that we are giving to you. So at this point, you need your calculator by you, because it's actually very important that you join us as we carry out the computation. So when you have your coordinates like this, will be represented in form of A and B, you can actually mean you're coming from A to B, right? So maybe if you have another coordinate C, then coming down, it can also mean from B to C. If you have another coordinate A, maybe trying to close the loop, it can also mean from C to A, right? Which means as these two coordinates are represented, or as they are written like this, one can easily say you are going from A to B. So you just have something like AB, not BA. So having established that, what we do is what? The coordinates of B minus the coordinates of A is actually the normal procedure we've been using on the channel, right? Good. So the northern coordinate is 1450. Of the northern coordinates of B is what? 1450, while the northern coordinates of A is 1350. So by the time we carry out the subtraction, which is 1450 minus 1350, we should be able to have 100. Therefore, our delta nothing is what? 100, as you can see here, right? Good. Now let's come to the delta easting. We have 1133.5, right? Minus 1000. So we're having 133.5, and that 133.5 represents what? Our delta easting, right? Good. Now we have our delta nothing and our delta easting. Therefore, those are our partial coordinates anyway. Therefore, we can now use those partial coordinates to get the distance and bearing between what? Line AB, right? So what do you do? Now, if you're using the Casio variant of the calculator, maybe Casio variant of the calculator, if you're using the Casio brand rather of the calculator, you can use the rec and the pole function on your calculator. So you just maybe press shift and then plus. You would see something like a pole asking you to impute the parameters or to impute the data. So the first data you are going to impute is what? Your delta nothing. So you just simply type 100, comma, then you type 133.5, right? Then you hit the equal to there. So what you should be seeing displayed depending on the type of Casio you're using. Some Casio display the two results, yeah, the distance and the bearing, or the delta nothing and delta easting in either case on the screen. However, using some other calculators, you have to press alpha tan or so to get the second answer. So depending on the calculator you're using, you should be able to see the distance displayed, and the distance being displayed there is what? 166.800 to 3 decimal places, right? Do you have that on your calculator? Please, if you don't have that on your calculator, you should just do it again, because that's the distance. Then the bearing is simply what? When you have your bearing like that, all you do is what? Just say alpha y. Then when you type alpha y, just hit the degree there, and then you should be able to see what? Your bearing in degree seconds, right? So alpha y degrees should be able to display your bearing in degree seconds. And what's the bearing there? We have 53 degrees 9 minutes 52.03 seconds, right? So that's the distance and bearing between line AB. I hope you actually follow the truth, because as we are recording the video now, we are also pressing our calculator just to be sure. So maybe if there's any typographic error, we can just cite it or maybe call it out immediately. Now, given that that's the angle, the next thing now we want to look at our angles. Given that the angle A is 50 degrees 5 minutes 26 seconds, how do we know that BAC? So we know that it's actually angle A. Then, or let's say, and also angle B is 321, However, surveying being a physical science, one can be able to deduce on a scale of 1000, you cannot have 100 meters shorter than 50 meters on a scale of the same scale, like equal scale, because surveying is actually a physical science. When you measure 100 meters, it's ideal to be longer than 50 meters, and it's ideal to be shorter than 200 meters. So proportionately, you know what you're supposed to have. So when you look at an angle like this in a triangle, in fact, you cannot even have 321 in a triangle, because the sum of angles in a triangle is actually 180, which means this actually exceeds what this value here exceeds the sum of angle in a triangle. Therefore, what do we now do? The equivalent can actually be gotten by using the idea that the sum of angle at a point is equal to 360, right? Good. So the sum of angle at a point is equal to 360. Therefore, when you subtract this value here from 360, you can now have the equivalent angle for what? For B. So this angle here can be seen as the external angle. Then the other equivalent angle of 38. How do we arrive at this 38 degrees 4 minutes 16 seconds? We subtracted this external angle from 360, and by subtracting it, why did we do that? We did that because looking at the triangle, we cannot have this in a triangle, number one, and even though maybe it's supposed to be, it's actually to be, in fact it cannot be. So that's how we were able to understand that, yeah, we are supposed to have something like this. So by that 38 degrees 4 minutes 16 seconds, which is actually the external angle subtracted from 360, is now proportionately what the angle B, which fits in our triangle. So since we know that, remember that the sum of angle in a triangle is equal to what? 180, which means the alpha, beta, and the C variant should give us what? 180. So since we want to get the C variant, it's actually a simple thing we do in mathematics, right? So you already know in 4, you know 3. Therefore, you can make the unknown the subject of the formula to find the value of that unknown, right? So since we know A, B, but we don't know C, and we know that their sum is 180, so the best thing for us to do is to do what? Is to add A plus B plus C, which we don't know, equal to 180. So by the time we add A plus B, which is in 50 degrees 5 minutes 26 seconds plus 38 degrees 4 minutes 16 seconds, we were able to arrive at, please ensure you press this thing on your calculator to confirm. So we're able to arrive at what? 88 degrees 9 minutes 42 seconds. Now subtracting that from 180, which is the sum of angle in a triangle, you are supposed to arrive at what? 91 degrees 50 minutes 18 seconds. I hope you confirm this answer. So that's 91 degrees 50 minutes 18 seconds is the value of what? Angle C, right? That's the C variant we are using. Now there's a note we left here which says back bearing, that's BB, plus observed angle, which is OA, is equal to forward bearing. We are going to use this idea when we want to get the bearing of AC and the bearing of BC. So you just have to pay attention to this particular note, and you can also use it in any other procedure of maybe surveying, whereby you have your back bearing, or you have two bearings and you need an angle, or maybe you have an angle and a bearing and you need another bearing, but it's actually a very important relationship. So now, from the triangle, we have been able to get the three angles in our triangle, and we also know one of the sides. This C variant, how do we know C variant? We know C variant because we know distance AB, right? And how did we get distance AB? We got distance AB by carrying out back computation, which we have actually done. That's 166.8, right? So that's the distance, or maybe, yeah, that's the distance C variant, or maybe that's the length AB, right? In your triangle, the side opposite your angle actually is the small letter, yeah, small letter of that particular angle. So we have A, B, C, or whatever the case is. So we are now going to use the sine rule. Now the sine rule is a relationship in mathematics that allows you to get either your side or your angle, your distance or your angle in a triangle, right? Good. So where we have what? A equal to B equal to C. That's A over sine A equal to B over sine B equal to C over sine C, right? Good. So now by A, we already know what A means, as we said, the side opposite your angle, the side opposite your angle, and the side opposite your angle. So the upper case represents your angle, whereas the lower cases represents what? Your sides, right? And you can actually see the lower cases as our numerator, and then you can see the upper cases as what? Our denominator, which represents what? The angles. And they also have what? A trigonometric identity, sine, attached to it. So now when you look at this particular triangle we are working with, we know C, we don't know A and B. We know angle C and we also know side C, but we only know the angles A and B. We don't know the sides A and B. Therefore, we can actually equate this C, which is complete, to either B or C, or we can equate C to B and A. Rather, we can equate C to what? B and A, thereby getting the sides A and B at different points, right? So now let's look at this other side, which means that B over sine B equal to what? C over sine C. Why are we doing that? We are doing that because we already know all the parameters that are on this side of the equation, on this right hand side of the equation. However, on this left hand side of the equation, we only know our denominator, we don't know the numerator, right? Good. So by simple mathematical operation of change of subject or formula, we can be able to deduce that our B, which is the small letter b, is equal to C multiplied, that small letter c, multiplied by sine B all over what? Sine C. Please, you need to confirm this by yourself, right? Small letter c multiplied by sine B all over what? Sine C, as you can see it here. Because by the time you cross multiply like this, you have small letter c multiplied by what? Sine B equal to small letter b multiplied by what? Sine C. So by the time you divide both sides by sine C, you should be able to have what? B standing alone equal to small letter c multiplied by sine B all over sine C, right? What we are now going to do next is that we should now impute the values. So we already know our small letter c, which we told you earlier, which is the side AB. We already know the distance, right? The length. We already know the length. And that's what? 16.8. Multiplied by sine B. And what's our B? The angle B, as we deduced the hour, was what? 38 degrees 4 minutes 16 seconds. Divided by sine C. The C is actually the third angle that we got from the sum of angles in the triangle, right? So we have what? 91 degrees 50 minutes 18 seconds. So by the time you carry out this simplification, you should be able to arrive at what? 102.908. Ensure you confirm this thing on your calculator so you know that the answers are correct. Now, coming to the second relationship, which is comparing A with C, because we have known what B is now, and B is simply what? AC. As you can actually see here, B is what? AC. So we want to now know what A is, which is what? BC. So comparing what? A over sine A equal to C over sine C, and making A the subject of the formula as we did earlier, we have what? C sine A all over what? Sine C. So we already know what our C is, 16.8 multiplied by sine A, which is the angle A. And the angle A is what? As we got earlier, 50 degrees 5 minutes 26 seconds, right? Good. So we have 166.8 multiplied by sine A, which is 50 degrees 5 minutes 26 seconds, divided by sine 91 degrees 50 minutes 18 seconds. So by the time you carry out this simplification on your calculator, you should be able to arrive at 128.011 meters, and that's actually what? Your length BC, which is what? This length, right? Good. Now let's try to get the bearing. That's where this particular footnote will come into play. Now we told you earlier on that back bearing plus observed angle is equal to forward bearing. That's just a simple rule we use in traverse computations, right? Good. So let's look at this particular condition. We already know that from A to B we know the bearing, but we don't know the bearing from A to C. But we know that from A to B is what? 50, right? Good. So if from A to B is, sorry, that's not 50, it's 53. If we know that from A to B is 53 degrees 9 minutes 52.03 seconds, and we know that an angle was turned from that A to C, no longer to B, which means if we want to get the bearing, remember we said an angle, not a bearing. Since we know the bearing A to B, and we know that an angle was turned at A towards C, It simply means that we are now going to use that direction, which is AB, plus the angle that was turned to now give us this other direction of what? AC. That's what we did here. Therefore, bearing AC is equal to what? The angle AB, sorry, the bearing AB plus the angle observed at what? At point A. That's the simple thing. So if you look at this particular relationship here, you can see back bearing, any bearing plus observed angle equal to forward bearing. Are we together? Good. So we now know that this bearing here plus this angle will give us what? This bearing. So the bearing AB plus the angle observed at A will give us what? The bearing AC, right? Good. So we have 53 degrees, 9 minutes, 52.03 seconds plus 50 degrees, 5 minutes, 26 seconds. So ensure you confirm this on your calculator. You should be able to arrive at 103 degrees, 15 minutes, 18.03 seconds, right? Good. So that's bearing AC. So we already know distance AC and we now know bearing AC, which means we are getting very, very close to getting the coordinates of what? C, right? Good. Now let's also get the bearing BC. Now coming down to B, you know B was actually gotten from A, right? We identified, or let's say we located B by coming from A, going a distance of 166 meters, 166.8 meters, and at a bearing of 53 degrees, right? So that's how we arrived at B. So whenever you want to go from B to any other point, at least you need to reference to A, right? So by referencing to A, it becomes a back bearing, because from A to B is a forward bearing. Therefore, from B to A will serve as for, or will be your back bearing. So if from B to A will be your back bearing, it will be plus or minus A to B, right? And the sign may be adding or subtracting depends on the value. So the value we have here is 53. So by the time we add 180 to 53, we should be able to arrive at what? The bearing BA. So 180 plus this gave us what? 233 degrees, 9 minutes, 52.03 seconds. Ensure you confirm that on your calculator. Minus B, minus B. Remember, we are working within this our triangle. So whatever we are doing, we should be able to understand the relationship. Now in this case, it's no longer addition, because by the time we add, we should be able to exceed, maybe extend our triangle, which will now affect our angle. This particular angle here, because it will be wider, and we already know the angle here. So it will be minus B in this case. So when we have minus B, which is what's our B? We have our B to be 38,416. So that will give us what? 195 degrees, 5 minutes, 36.03 seconds. We hope this explanation has been very, very simple. And if you have any challenge, you can actually pause and you rewind, and then you get it exhaustively and you do what? And you proceed. So now with this, we have been able to get the distances and the bearings of all of the length, right? We know that of AB earlier, it was given. We have computed that of BC, and we have also computed that of what? AC. So having established the distances and the bearings of what AC and then BC, we can now get the coordinates of C, right? Using those distances and the bearings. Good. To get the coordinates of C, we need to move from A and B. That is AC and what? BC. This is what we mean. To get the coordinates of C, we need to move from A and B. That is what? AC and what? BC. So we are going to get two coordinates, which will now what? Average, right? By AC, we already know our distance and the bearing. And then by BC, we already know what? Our distance and the bearing, right? We actually computed them earlier. This is the distance, and then this is the bearing. Then the distance of BC is this, and then this is the bearing of BC, right? So that's what we just extracted and we kept here. So from A, using AC, that means coming from A, trying to identify the coordinates of C, we are going to use this distance and this bearing. Now on your calculator, earlier on you used pole to get the distance and bearing. Now you will use rec to get what? The partial coordinates of delta easting and delta northing. So using this distance and bearing, just press shift minus on your calculator. So that will give you a command called rec, and the input will be what? This distance and this bearing. So the first thing is what? Your distance, which is 102.908, right? Comma the bearing of what? 103 degrees, 18 minutes, then 18.03 seconds, right? So if you add that on your calculator, you should be able to arrive at a delta nothing of what? Minus 23.595 to 3 decimal place and 100.166. Please, was that what you got on your calculator? If that's not what you got on your calculator, you need to press it again because we are still confirming the answers here. So by the time you use the rec command on your calculator using imputing your your distance and your bearing as your input data, you should be able to arrive at what? Minus 23.595 as your delta nothing and 100.166 as what your delta is. So having established that, we now know the partial coordinate, which will now apply to what? The coordinate of A that was given to us, because we're actually moving from A. Therefore, the coordinates of C from A will now be what? The northern coordinate added to the delta nothing, and then the eastern coordinate added to what? The delta eastern, right? So the northern coordinate given to us is what? We have 1350. Then what's the delta nothing? We have the delta nothing of minus 23.595. So you should be able to arrive at 1326.405, right? 1326.405. Then the next one is what? 100 plus 1000 rather plus 100.166. So that should be able to give you what? 1100.166. So that's your northern and eastern coordinate respectively of point C from A. Are we together? Of point C from A. Now remember that there are 2 points where we are going to move from. So from B using BC, and by using BC we mean using these parameters of this parameter of distance and bearing. So we still use the rec command, which is what? Shift minus, which gives you rec. Then what's the distance? We have 128.011. Then comma, we have a bearing of 195 degrees 5 minutes. Then 36.03 seconds, right? Good. So you should be able to arrive at a delta nothing of minus 123.595. Is that what you got? To 3 decimal places. Then your delta eastern should be what? Minus 33.333, right? Good. Therefore, the coordinates of C from B. Now we already know the coordinate of what B as given to us from the equation. So the delta nothing the nothing coordinates of B as given to us is what? 1450. So it will now be 1450 plus what? 123. So plus times minus is actually minus. So just simply minus 123.56. Then you should be able to arrive at what? You should be able to arrive at 126.405. Are we making a mistake somewhere? Okay, this is supposed to be 595. Sorry, it's supposed to be 595. So not 56, 595. Good. You see, we're actually pressing on our calculator. So this is not 56, please. It's supposed to be 595. When we have 595 here, our difference is supposed to be what? 1326.405, right? So that's the northern coordinate of C as gotten from B, right? So in the same vein, let's do that for the eastern. So it's simply what was the eastern coordinate of B? The eastern coordinate of B is what? 1133.5 minus what? 33 point what? 333.333. I think there are 2 typos here. There are 2 typographic errors here. We are sorry for that. So minus 333. So we should be able to arrive at what? 1100.165 meter eastern, right? So we now have 2 coordinates of what? Point C, that from A and that from B. And to get the final coordinates of C, what we simply need to do is what? Is to find the average. So the first northern coordinate is what? 1326.405 plus the second one is still what? 1326.405 divided by 2 should be able to give you 1326.405. Ensure you confirm on your calculator, please. Then that of the eastern, we have 1100.166. then 1100.167, which is this. So by the time you add them and divide by 2, or maybe when you get the average, you should be able to arrive at 1100.167. So with this, we have been able to, as requested in the question, we have been able to determine the coordinates of point C using this parameter given to us, that's the coordinates of A and B, and then two observed angles. So yeah, thanks for coming to class. We hope we've provided solution to this particular solving problem. If you have any issues similar to this, or maybe even if not this, and you want us to assist you, you can actually contact us using any of our details, and we'll get back to you as soon as possible. So you can maybe give a like to this video, subscribe if you've not, and share with your friends, and leave a comment to encourage us. We are going to see you in our next video. Until then, keep being good at what you're doing and have a nice time. Bye.